Okay, welcome back to Math 160. The first thing I wanted to talk to you all about was the fact that you have Unit 9 assignments, and more specifically, I have actually given you 2 websites that I need you to use, okay? When you are going to calculate your p-values for testing a claim about a proportion or testing a claim about a mean, I need you to use these websites. You will not, and I repeat, you will not use your tables. The z-score table and the t-table, you are not going to use that for this homework assignment. For these 2 homework assignments, you will not use it. For this first hypothesis test basics, I don't think you need these sites, but just in case, I would open each of these up. I would open this one up. I would open your second one up. So you see how this one's for the t-test. This one is for the z-score. Keep both of these websites open. Then I would go into the homework assignment. I will say you probably won't need it for this first one, like I said before, but you will definitely need it for your hypothesis testing advanced. You're going to need exact values. Those 2 websites will give you the exact values. The tables will not. So please don't frustrate yourself by using these tables for that homework assignment. Use the actual online calculator so that you can get the specific values that you need. All right, any questions on that? Okay, so keep those open, use these websites. Your Unit 9 application, it's also very quick, much like Unit 8. So you're going to do the same thing, open a Word document, put your name at the very top. You are going to notice you have 58 values here. You're going to test the claim that adults watch more than 3 hours of TV each day. You're going to conduct a hypothesis test at the 0.05 significance level to determine if we should reject or fail to reject our null hypothesis. Real quick, what's our alpha? It's right there. What's our alpha?
0.05.
Thank you. That is correct. 0.05. This is your alpha. Okay, 0.05. We're essentially saying we are 95% confident with a 5% error, right? Alpha 0.05. Think type 1, type 2 errors. Go back to that chart and look at how type 1 and type 2 errors play into this. Also think back to the trial when we talked about the innocent person, or are they so innocent? Are they guilty? Right, that kind of thing. So go back to that section if you want to really understand the type 1, type 2 errors. But anyways, alpha is 0.05. Good. You're going to follow these steps exactly to conduct your hypothesis test in Minitab. If you do not have Minitab and you're using Excel, I got you covered. I already uploaded the video. It's performing a hypothesis test using Excel. I will tell you this one's a little bit more interesting. It's a little bit more involved. So I would have this open and I would watch it as you are conducting your hypothesis test. Okay, follow along exactly. The one thing you're going to need to do this for your Excel is the data analysis tool. So I will send you instructions on how to download it. It's really easy. It's an add-on. It's like super fast. You click it, boop, and it's in your Excel. So I'll send you instructions on how to do that and you'll be just fine. It doesn't take very long at all. And then you just have your 3 statements. State your decision and how you reach that decision. Is your p-value less than your alpha? Is your p-value greater than alpha, right? Think about that. You're going to state your conclusion, and then you determine whether you could have made a type 1 or type 2 error. All right. Any questions for me on this? Good. Everything is in here, like I said, and we're nearing the end of this course. I will tell you that if we do not finish our notes today, which we probably won't, and that's okay. If we don't finish our notes today, I will finish our notes tomorrow. I will record the last little bit that we need. Maybe I'll get it done today. It depends on what I can accomplish today. I will finish recording, so you will have that, and we will be done with Unit 9, which means all of next week, I would like to dedicate to review, okay? Monday and Wednesday will be straight up review to make sure that you are all solid. Today, you will also receive your part 2 of your final exam. That is the take-home part. That part 2 of your final exam will be due the day of the exam at the start of the exam. There are no late assignments. There are no makeups. It's a final, okay? Please understand and heed what I am saying. I will not accept a late final. If you're turning in a late part 2 of your final, you get a 0 for the final, which means you don't pass the class. Don't let that happen. That's a crazy, crazy predicament to be in. You'll have plenty of time to complete it, over a week to complete that part 2 of your final. Don't be the case that doesn't turn it in on time, okay? I'm gonna type in the due date and say it out loud to everybody and email it to all of you. The part 2, Nick, I'll be right with you, of your final exam is due no later than 12 p.m. noon on December 20th, the date of your part 1 final over Zoom. Okay, there it is. It's due at the start of your part 1 final. Nick.
When is Unit 9 due for the homework assignments?
Let's come up with a due date. One thing I was contemplating doing with all of you in terms of helping you to prepare for the final is opening all of your homework assignments up and letting you have an opportunity to complete that. Is that something you would like for me to do?
Yes, please, please, please.
Okay.
Are you talking about like putting everything into a combined homework?
No, I'm saying I want to change all of the due dates to be December 20th at noon. So you'll have over a week in case you have assignments that were passed and you're like, damn, I really wish I had time to do those, especially since it's going to help me for the final. I will open all of the homework assignments up. I will give you an opportunity to get those grades up for your homework and get them completed by Monday, December 20th at noon. Sounds good.
Oh, I thought you were making like a practice exam type thing.
We do have review packets, so I will share that. But no, I mean, in terms of the due date for the homework assignments, I'll give everyone an opportunity in case they miss some to complete all of those. Okay.
Oh, okay.
So everything will be due that date, and I'll reflect that in Lumen. Nick.
Oh wait, I'm sorry. I don't know why it was still up. My bad.
That's okay. That's okay. Good. All right. I don't have any objections about that. That does not include the applications. That just includes the homework. Okay. So just the homework, you'll have an opportunity to complete those. All right.
So everything for Unit 9 will still be due on the 20th.
Yeah. Including
Okay.
the application. Including the
Okay.
Good. By the way, I would get this done as soon as you finish learning about Unit 9, because it's going to be so fast and you want that out of the way.
Okay. And
Quick
then
question. When he's done.
you're gonna, just to clarify, you're moving not all of chapter 8, everything except the application for chapter 8 to the 20th, correct?
Yeah, I'm actually putting all of the due dates for all of the homework assignments to the 20th.
Okay, I just have the Unit 8 and Unit 9, so I'm fine. All right, thank you.
So including the application or no?
Not including the applications, no, just the
Okay.
homework assignments. Good. Good. Stephanie, did you still have a question?
Yeah, I was wondering where the part 2 of the final is on Lumen.
It's not there yet. You will be receiving that today from me, and I'll give you all that information via email.
Okay, thank you.
You're welcome. Good. All right. I feel like that covers everything. Part 1 is going to be over Zoom, Lucy, on the 20th, because we meet for the final exam. That's that multiple choice part. So on the 20th at noon, we'll meet over Zoom, and that's when you take your part 1. Okay, cool. Score. All right, let's pick up where we left off, which is 9.2, page 9.
I actually,
Ooh,
I
yeah,
actually have one more question.
sure.
For the final, can we have the tables that you gave us? Can we have those out too, like along with like the reference page?
Absolutely. What I'll do to make your life easy is I will give you like a file that has all the tables on it. So you can print that out if you want, or just collect the tables that you had.
You know what?
Along
I'd
with-
rather print it out. It would be easier for me. I feel,
Fresh one,
yeah,
along with your 1-page formula sheet. One
Okay.
page formula sheet. You can have those items, the tables and that 1 page. Okay.
okay. All right, thank you.
You're welcome.
My formula sheet is like stapled together because I kind of write kind of big. Is that okay or no?
We are going to, worst case scenario, we will actually create a formula page. Is something that I will send out to everyone. Okay. So
Okay.
create it and make sure that it fits nice and neat.
So it can only be one whole page.
Yes, technically, and it's always been that way. 1 whole page for everyone. I know it's silly, but it is what it is. I guess it prevents people from like bringing a whole freaking guided notes packet. Jenny.
Yeah.
Front and back or just one side?
From my understanding, it's always been just front.
Okay.
But let me double check just to make sure. I know it's silly. Again, let me just double check. It used to be just an index card. Then they were like, how about a page? So let me double check on that to make sure that I am meeting requirements for the final. That's the last thing I want to do is, mess with that. Cool. Thank you for asking. I will find out all of that information. Let's continue in Unit 9.
I just have a quick question.
Stephanie.
I was just wondering how many questions are on part 2. You know,
Oh.
like,
That's probably around like 8 to 10 questions.
okay,
Yeah.
thank you.
You're welcome. All right, let's make this happen. 9.2, testing a claim about a proportion. Hypothesis testing procedure. There are 2 approaches for testing a claim about a population proportion. We will only be using the normal distribution as an approximation to a binomial distribution. Do you remember that? Your P's and your Q's? You may not use a confidence interval estimate when testing a claim. So there are some requirements here that must be met in order to actually test a claim about a proportion. The first thing is that the sample observation are a simple random sample. So all of those values, they're from a simple random sample. Conditions of a binomial distribution are met. N times P is greater than or equal to 5, N times Q is greater than or equal to 5 are both satisfied. So the binomial distribution of sample proportions can be approximated by a normal distribution. Remember that your mean is calculated by multiplying N times P, and that your standard deviation is calculated by taking the square root of the product of N, P, and Q, okay? But this is all old stuff. We've done this before when we talked about the binomial distribution. We have a formula for the test statistic for testing a claim about a proportion. This is definitely going to be on your formula page. Whatever formula page you're constructing, this formula is going to be on it. So this is your test statistic for testing a claim about a proportion. When you write this on your formula page, I would include the name, just so that you know exactly where you are and what you're doing with it. So definitely something to keep in mind. We see that Z is equal to P hat minus P divided by the square root of P times Q over N. Let's turn the page and see how we use all of this good stuff. Practice number 3. A certain drug is used to treat asthma. In a clinical trial of the drug, 16 of the 288 treated subjects experienced headaches. The manufacturing company claimed that less than 12% of the treated subjects experienced headaches. assume a 0.05 significance level. So we want to check this out and see what's going on. First off, let's determine if we meet the requirements. So recall n times p. What is n in this case? Does anyone see it?
288.
Yes, 288. Perfect. N is 288. Do we see our alpha? Would somebody share the alpha?
It would be 0.5.
Yeah, 0.05. Perfect. Beautiful. We can actually also write down our p-value. Our p-value in this case is going to be the 12% of treated subjects. So we're looking at the idea that the claim is, right, the manufacturing company claimed that less than 12% of the treated subjects experience headaches. So p is going to be 0.12. We do also have to calculate p hat. P hat in this case is going to be the 16 out of the 288. We're essentially looking at, well, what does the sample data tell us, right? They ran a clinical trial. So what does that tell us? What information did we get? Well, we were told that 16 out of the 288 people experienced headaches. So let's go ahead and punch this into our calculators. When we do this, we get 0.0556. So it's kind of looking good, isn't it? So the manufacturer is claiming it's less than 12%. The clinical trial shows it is, but we want to really test this to determine what's going on. So let's start with our requirement check. I want to show that n times p is greater than or equal to 5 and that n times q is greater than or equal to 5. We know that n is 288. P is 0.12. If you were to multiply those two things together, for a fact, it's going to be greater than or equal to 5. That's without question. I have a question for all of you. If P is 0.12, what's Q?
0.88.
Yeah, and how'd you get that?
Well, mine is 0.12.
Yeah, so 0.88. Nick says, well, we know that the sum of P and Q has to be equal to 1, right? Think success and failure. If there's a 12% chance of success, then there's an 88% chance of failure. This goes back to that binomial distribution content. Good. I love it. We have lots of information here. We also note that we have 2 outcomes. So I'm going to make a note of this.
Just for reference, can we put what P and P hat, like what they mean on the side, like a little definition, just so we can remind ourselves?
Yeah, so this is essentially the sample proportion. Think of the fact that we got this data from that clinical trial, which is a sample. That's sample proportion. Good. Versus population proportion.
Yeah, that makes more sense because I was reading, I was like, what's P hat again?
Yeah. No, I totally get that. It's kind of interesting because you think about like mu population mean and then X bar sample mean. That's kind of the same idea with P and P hat.
Are we ever gonna need like a Q hat?
No, nope, no. I have never seen a Q hat. I would have to talk. That's a great. I would have to talk to like some of my colleagues, but I'm like 98% certain. See, I'm 98% confident that there is no Q hat necessary.
If not, I won't be the first one to figure it out.
So like when we say significance level, and then that's the amount of error, what does that mean exactly?
Think about the fact that essentially what we're saying here is that we have a region of values and we're feeling that the true population proportion is going to be within that value, that range. But when we say, for instance, we're 95% confident, that means we're 5% not confident. I know that's a weird way of saying it, but it's kind of true. So we're saying we're 95% confident with a chance of a 5% error. And that error is that significance level in this case, because we want to make sure that we're meeting that significance level. We can make that tighter. Like if I said, you know, I want it to be 98% confident, then the error is going to be 0.02, right? That's our alpha. So think about that relationship. We can make that error smaller, which means we're being more, we're being a little less strict because we're opening up the range of values here, but we can make that error tighter, right? So
Like
it's smaller.
statistically significant, what does that mean when it comes to like the error?
So statistically significant means that when we compare our probability with our alpha, if we see that our probability is smaller than our alpha, we actually have the ability to say, let's reject the null and claim and state that there's something significant happening, that it's not business as usual, that there's something else that's going on with this particular study, with this particular research, right? So it allows us to say that there's something worth investigating. There's evidence to show that. And I think that's the key part for hypothesis testing. We're saying, do we have enough evidence to reject the null? If not, we have to fail to reject it, which means we're going to have to say that it is business as usual, or so we think.
So like nothing's happening.
Yeah, exactly. It's like, no, it seems like it's business as usual. We failed to reject the null. It's fine. Everything's normal. It's exactly what it is. It's like the boring result. But if you reject the null, you're saying, whoa, there's something very interesting happening here, and it's statistically significant.
Okay.
Cool. So we have two outcomes for this particular problem, and that is they either have a headache or they don't. So headache, no headache. That reminded me of Coco. Dimple, no dimple. Dimple, no dimple. So headache, no headache. So we want to write the null and alternative hypothesis. Because we haven't seen this since last week, I'm going to go ahead and set this up for you. The null hypothesis, the business as usual hypothesis, is that the proportion is 0.12, right? The claim, the manufacturing company is claiming that less than 12% of the treated subjects experience headaches, but the business as usual is that it's actually equal. So the proportion is equal to 0.12. So let's write our alternative, which is that the proportion is less than 0.12. And I'll underline that here just so you can note where that's coming from. So we want to test that claim. Is this a two-tailed, left-tailed, or right-tailed test?
Left tail?
Yes, excellent. This is a left-tailed test. How do you know?
Because the alternative is less than 0.12.
Perfect, because the alternative is less than. If this were greater than, it'd be a right-tailed test. If this were not equal to, it'd be a two-tailed test. Very nice. So we want to go ahead and we want to calculate the test statistic. We have a formula for that. I'm going to go ahead and write it again for you so that
I have a question.
Yeah, go for it.
How did we get the null hypothesis to equal 0.12?
It's always equal to 0.12. So from my last video in class, you'll see that every time we write the null hypothesis, it's always equal to the value.
Okay.
Perfect. So here's our formula. Z is equal to p hat minus p all over the square root of p times q over n. So carefully, we want to plug in our values. P hat is 0.0556. P is going to be 0.12 divided by, be really careful, this is just regular P and Q. It's not P hat, Q hat. So we have the square root of P, which is 0.12, times Q, which is 0.88, all over N, which is 288. My advice to you all, when you're taking your calculators, you should be doing this, and punching this in, I would literally just do the numerator first, enter that and write it out. You should be getting, excuse me, you should be getting negative 0.0644. Then I would take the square root and I would just input everything I see here. So 0.12 times 0.88 divided by 288, and then close it and press enter. I literally just typed it in exactly as I saw it. So 0.12 times 0.88 divided by 288, that left me with 0.0191. I'll round to this place, 5. And then remember, we're writing a z-score. So the z-score must be rounded to the hundredths place for us to use the table. I'm going to make a little side note. When you are calculating your z-score for your homework and you're using the online websites, you can actually leave your z-score to whatever place you want, which is really cool. So if you get a z-score that's like to 4 places after the decimal, type that whole thing in there. It'll work. It's really, really cool. It'll give you a very accurate answer. So when we punch this value in, you should have that z is equal to negative 3.36. So I'm just going to put a box around this. That's our z-score, negative 3.36. I drew the curve for you just so you can plot that point still. Negative 3.36 is about here. I know you're thinking, how, what? It's so tiny. It's okay. I'm still going to shade in the region. Okay, so I'm still shading in that tiny, tiny, tiny little region. Go ahead and take your z-score table. And I would like you to look up the value negative 3.36 and then tell me the p-value. Give me the area under the curve. What do you get when you find it? What did you get?
0.00039.
Awesome. 0.00039. Beautiful. That is a negative 3.36 on the table. That is your p-value. That's your probability, p-value probability. So I'm going to write that here. P-value is equal to
0.0039.
Yes, exactly. 0.00039. Beautiful. So now we're ready to write our decision about the null hypothesis and explain how you arrived at it. Recall that we have to compare the p-value to the alpha. So we want to write p-value and we want to compare it to our alpha. Our p-value is 0.00039. Oh, Ava, great question. When you go to your table, your z-score table, you want to look up negative 3.36. So negative 3.36, and then you go to the intersection, and it's right here, 0.00039. So we use the z-score table to find that value. Perfect. Our alpha is 0.05. Notice that our p-value is definitely smaller than the alpha. So we can literally write, oh, the 0.00039 is less than 0.05. So what's my decision? What is my decision in this case?
Reject.
Yes, yes, excellent. We are going to reject the null hypothesis. Nice.
Can you explain why we reject it?
Yep. So when your p-value is less than or equal to alpha, that is your decision. Think of if the p is low, the null must go. That's what we talked about last time. If the p is low, the null must go. If your p-value
Probability is low.
yes, if your
Where
p-value
then?
is smaller than alpha, you reject the null. So something significant is happening. If the
Okay.
p-value is greater than alpha, you fail to reject it.
So can you say it in like, instead of p-value and alpha, like terminology, can you explain it in like probability terms and things like that, like error?
If your p-value is smaller than your cutoff point, your alpha, the allotment for your error, then you're going to reject it because something significant is definitely happening. I want you to think about this region here. So your probability is super small, right? But 0.05 is more of this region. It's a greater region than just this 0.0039. So think about the fact that this particular region is actually smaller than alpha. So there's something very unusual happening. Do you remember the idea about range rule of thumb, where we said, if you were within 2 standard deviations from the mean, those are your usual values. And then anything below or above those values would be unusual. Do you remember that?
Yeah.
This is the same kind of concept, except we're not given such a big space to determine, if it was usual or unusual. We're looking at 0.05 space, right? We're looking at this region that has a probability of 0.05. Because our z-score lands in this tail with a probability smaller than 0.05, we can literally say, whoa, that is very unusual.
So our probability is 0.00039.
Yeah,
And then it's smaller than that,
it is.
or
It's
smaller.
than alpha, or 0.05, which is like our cutoff value, right?
So our cutoff value is 0.05. And then our probability is less than our cutoff value. So it's even more unusual.
Yes,
Unusual.
absolutely. If this p-value were greater than the alpha, I want you to imagine that it's in the region where it's usual, right?
Okay.
But in this case, it's not, it's smaller. So we could be like, whoa, okay, something specific is happening here.
So where is our cutoff value on the thing? 0.00.
With 0.05, we actually have
Okay. Okay.
scores associated with that, and that would be found from our critical values table in unit 8, or we could even use our z-score table to find that as well.
So our cutoff value is 0.05.
Yes, that's your alpha, your significance.
Okay.
Yep. Perfect.
So that's the value where like to the right of it would be usual, and then
Yes. So essentially, because this is a left-tailed test, your 0.05, that z-score pertaining to that is going to be somewhere in here, and we're even smaller than that.
okay.
Good. Good. Remember this. This is going to be really helpful too. You want to remember these options. So if your p-value is low, the null must go. That's why I like that little mnemonic, because it kind of helps to remember that. If your p-value is greater, you're going to fail to reject because you don't have enough evidence. You don't have enough evidence to reject it. So you either reject or you fail to reject based on that evidence. So you're actually leading me right into how we would write the conclusion, which I think is going to be really helpful too. So here's what we will write. There is sufficient evidence at the 0.05 level of significance to show that, now notice we're showing that the alternative hypothesis is valid, to show that P is greater than 0.12, which means, what does that mean? What are we saying in this problem with P? Did I say greater? I mean less than. What are we saying that P is less than 0.12? What are we saying in the context of this problem?
So less than?
Yeah, like what
Less
does,
than 12% of the treated subjects experienced headaches.
yes, very nice. Okay, let's write that out. So P is less than 0.12, which means I'm going to use the word proportion since it's P. The proportion of treated people who experience headaches is less than 12%. And there's your conclusion. So remember, when we talk about your decision about the null hypothesis and explain how you arrived at it, you arrived at it by comparing the p-value to the alpha, and then the decision was to reject the null hypothesis. And then, of course, you always write your conclusion to follow. Let's do it again. Let's do it again. I think that's going to be really helpful to see a bunch of these. I'm going to turn the page. Practice number 4. A survey of 1,577 randomly selected adults showed that 583 of them have heard of a new electronic reader. The company claimed that 34% of all adults have heard of this new electronic reader. Assume 0.05 level of significance. Let's start by writing some information. Stephanie, what is my N in this case?
Wouldn't it be the 583?
Ooh, think bigger. What's the survey was conducted for how many people?
Oh, 1,577.
Yes, I love it. So we want to collect all of the people who have taken that survey. That's 1,577 of them. Excellent. Let's go with Carrie. What is my alpha in this case? Carrie, what's my alpha?
0.05.
Awesome.
I know P hat.
Ooh, all right, go for it.
583 over 1,577.
Yes, I love it. Which is what decimal? And to 4 places would be helpful.
0.3697.
Beautiful. And we also need a P. Lucy, in this case, what's P? What is our P?
Wouldn't it be the 34?
Yes, it would be. Beautiful. So we're going to write 0.34. So what's Q? If P is 0.34, what's Q?
0.66.
Yeah, 0.66. Very nice. So we know it's 0.66 because these two together have to add up to 1. So if there's 34% success, then there's 66% failure, right? You think about 100%. Love it. Let's do a requirement check. We see that it's a random sample. So I'm going to make a note of that. That's our first check. And then n times p is greater than or equal to 5, and n times q is greater than or equal to 5. I'm going to write it out, but you know for a fact that's going to be the case. When you multiply those two values, you're definitely going to get a value larger than 5.
We didn't put random sample for the previous one. Should we always write that?
No, you can meet different requirements, and that's okay.
Okay.
Awesome. We are ready to write our null and alternative hypothesis. So how about we start with Kelly? What is the null hypothesis in this case? What's the business as usual hypothesis?
P is equal to 0.34.
Beautiful. So this is business as usual, right? So we're basically saying the true population proportion is 34%. That's what we're thinking. But we want to test. We want to look at, so I don't want to give it away, All right, look at what it's saying. The company claimed that 34% of all adults have heard of this new electronic reader. What do you think the alternative hypothesis would be in this case?
Would it be those who have not? So it'd be like the equals with the slash through it?
Yes, perfect, Leah. You're absolutely correct. So we're saying it's different, right? It doesn't specify if it's less than or greater than. So we just have to say the alternative hypothesis is that, guess what? It's got to be different. Leah, excellent. What kind of a test is this?
Two-tailed?
Yes, it is. This is definitely a two-tailed test. I love this. Two-tailed test. That's really, really, really important to note. And I'm going to show you exactly why, although you probably already know, and that's totally cool, but we're going to do it
I
anyway.
have a question.
Yeah.
So you always talk about how we have to have requirements. Are we ever going to have a question on the final where we don't have
Oh,
the
wait,
required?
the requirements? No, I
Yeah.
won't do that to you.
Right.
That would not be nice.
Thank you.
Yeah, so I got you covered. It will definitely be possible to do that. Oh, that would be so cruel. That takes me back to my complex variable days where my instructor at RIT gave us a take-home test. Now, mind you, it was only to boost our grade, like it was kind of a bonus test. Yes, I took it home. Yes, I did it. Don't you know it took me 38 hours?
Oof.
I'm
I
not
took a statistics test another time and he gave us like times where it didn't like meet the requirements.
see that's
And
Always meet the requirements.
yeah,
And
yes. Yeah.
Oh,
I'm not gonna
like,
predict
are we gonna like have to look it up and like see if
no,
it?
I did. For that test, I had to look at
Oh
like
my God.
I had to look at theory. I had to look at proofs. It was insane.
Oh,
Insane. It was so insane. I was like, wow, okay, lesson learned. So, okay, calculate the test statistic. I can write the formula down again, but if you look at your previous, I'm just gonna write it. It doesn't hurt. And it's good to get into the habit of writing them down just so that it's easier every single time. You're like, oh yeah, I remember that formula. So P hat is 0.3697 minus our P, which is 0.34 all over the square root of P times Q. So 0.34 times 0.66 all over N, and N is 1577. Cool, let's punch this in. When you have the numerator, would you share that with the class?
.0297.
Yeah. Thank you, Nick. Someone else, when you have the denominator, would you share that with the class? And how about let's do 6 places after the decimal. You can just start listing the values off.
0.011929.
Love it. Beautiful. Let's go ahead and divide these two. And remember, we're using the tables for in class, not on the homework for unit 9, but in class, we'll use the tables. And so for instance, when you got a z-score like this, we would be rounding to the nearest hundredths place. You can actually just leave it like to 4 places after the decimal. When you type it in that website that I gave you, it's so cool. You're going to love it. And it's going to make your answers very accurate. So z is equal to 2.49. I round it to the nearest hundredths place because we have limited capabilities here in class. So we're going to use tables. Okay. Remember, this is a two-tailed test, which means we have a positive z-score and a negative z-score. So let's plot 2.49, which is approximately here. So this is a z-score of 2.49, but we also need its opposite, which is a negative 2.49. So we're going to plot that point. This is z is equal to negative 2.49. So essentially what we're going to do is we're going to look at the probability in both of these tails.
It's I just lost it, 0.9936.
Oh, so you
Oh,
actually want to start with the negative side.
Oh,
You
yeah.
want this little guy.
Oh, yeah, because to the left. Okay.
Yes,
Never mind.
yes, beautiful.
I have it.
Go for it.
0.00639.
Yes. 0.00639, which means the area above is going to be the same. They're identical. It's symmetric, right? It's symmetric about the mean, so they have to be the same. I'm going to make my squigglies kind of look the same. Perfect.
I knew that didn't sound right.
You're
Just
like,
reading, I was like, wait.
yeah, no, that's okay. And now the p-value is just the sum of those two. So let's determine the p-value. And I'm going to write out 0.00639 plus another one. You could write multiplied by 2, whatever your heart desires, or you could just say add the 2 up. So your p-value is 0.01278. Good. We are going to compare the p-value with alpha again, as always. So p-value, alpha. I always like writing the labels above the numbers, just so that when I look back in my notes, I can be like, oh yeah, I know exactly what I was doing and where I was going. We'll write out our p-value. We'll write out the alpha. And then notice p-value is actually smaller than my alpha. So my decision again is going to be,
Reject.
yeah, reject the null hypothesis. We're going to reject the null hypothesis. And now let's write our statement. I like this because it's so like, I mean, it's repetitive, but I actually like that because it takes away a lot of the guesswork. So there is sufficient evidence at the 0.05 level of significance. Do you see how we are always including that significance level? When you're writing significance, sorry, I was trying to talk and write at the same time. When you're writing your responses to your part 2 of your final, make sure you're looking at this stuff, okay? Make sure you're looking back at your notes to ensure that the language is exactly the same. So, by the way, a take-home final means you can use your guided notes. Just putting that out there. A take-home final means you can use your resources. Just don't copy off of each other because it's not cool. I don't know why people do that. It's not cool, it's not fair. Imagine if you're the one busting your ass, doing all the work, and then Joe Schmo over here is like, hey, let me look at that. I just want to copy all your stuff. That sucks. That's the worst. Don't be that person. We had a person like that at RIT. It was the worst. We literally tried to hide from this person because they would show up when we finish and then they would copy everything down. Nasty. Not cool.
Oh, the page we can write down all the,
The formulas,
yeah, can we use both sides or just one side?
I'm gonna verify that. So I will have an answer for you very soon.
Okay.
Cool. So there's sufficient evidence at the 0.05 level of significance to show that P does not equal 0.34, which means that the proportion of adults who have heard of the new electronic reader is, and you can write this in two ways. You can say is not equal to 0.34, or you can say is different than 0.34. It's up to you. You can use either way of saying this. I'm going to say is different from. You don't have to. You can write is not equal to. It means the same thing. Now, there's actually one more part to this, okay? And what may help is going back to your table. And actually, I'm just going to do that because I feel like it's going to be super helpful. If
I have
you
a question.
oh yeah, go for it. That'll give me time.
Can we say it's different from 34%?
Sure,
like the
yes.
last one? Okay.
Yeah, absolutely. Absolutely. That's a great question. I'm opening up your Unit 8 notes. And I'm looking for, was it Unit 8 or Unit 7? It might be Unit 7 with the type 1, type 2. That was Unit 7. I'm going to open up Unit 7 notes. And I'm going to share my screen in just a moment.
I also have a quick question.
Yes,
For the
go for it.
part 2 of the final, are we going to, is it like you open it, you have to do it right then and there, or is it?
Oh no, you're going to end up, you're probably going to end up printing it out.
Okay.
Yeah, you're probably going to print it out. You're going to end up writing all over it, that kind of thing. You might even write all of your stuff on a separate sheet of paper.
And then are we sending it via PDF
Yes,
into Lumen? Okay.
yes, absolutely.
Okay.
Absolutely. Is it these notes that the chart is on? Man, what am I thinking? It is. Wow. Okay, so at the very beginning of this set of notes, I'm going to turn back. Here it is, page 4. So let me turn the page just so I can show you what we're about to do. Part G says, determine the type of error you could have made and explain what it means. So this is when we use the table on page 4, okay, of these notes. So if you go to page 4 of these notes, I want you to notice what we did. We rejected the null. So I'm going to make a note. We rejected the null. That's going to be really, really helpful in determining what type of error we could have made. So if you
Page
look
4
at,
of Unit 7?
no, this unit, Unit 9.
Oh,
Yep, same unit. It's on the 4th page of these notes. I don't know why I thought it was in a different set of notes. So you start here, right? So if you fail to reject, that's not what we did. If you reject the null, that's what we did. So if you reject the null, you could have made a type 1 error. So you could have made the correct decision, or you could have made a type 1 error. And there it is. That's how you use this chart. If, for instance, we failed to reject the null, we could have made a type 2 error. So anytime you see this particular question, go back to the chart. If you, and then choose which one you did, and then you could be like, oh, okay, I made a type 1. I could have made a type 1 error. So let's write that out. And that was page 4 of your notes. Let's go back to what we were writing. And we will say, we could have made a type 1 error because it could have been true that the proportion was equal to, and then you can write 0.34 or 34%. I'm just going to write 0.34. So remember that we rejected the null? We could have made a type 1 error, which means it could have been true that the proportion was actually equal to 0.34, even though we rejected it. Any questions on that? Good. Very, very cool. So we're going to do the exact same thing. I'm just kind of looking through because it seems like we essentially have the same ideas for the rest of 9.2. So let's see if we can do an entire problem in the last few minutes of class. All right, let's start this again. Let's breeze through this. In a recent poll of 750 randomly selected adults, 586 of them said it was morally wrong to not report all income on tax returns. Use a 0.01 significance level to test the claim that 75% of all adults say it is morally wrong to not report all income on tax returns. All right, let's start off. How about we begin with Ho? Would you give me one piece of information that you are given? Oh, Lucy, you started us off. I love it. Thank you for writing that in the chat. She says, hold on, I'm going to start this off. N is equal to 750. Beautiful. Oh, give me another piece of information.
So I see that P should be 0.75.
Yes, P is 0.75. So what does that mean about Q?
That means Q should be 0.25.
Perfection. Thank you. Oh, Sam, give me another piece of information.
Okay. P hat is 586 over 750.
Yes, 586 over 750, which is what decimal value to 4 places?
0.7813.
Love it. And we need one more piece of information. How about Ava? Give me one more piece of info that we see from this word problem.
The, what's it called? The little infinity sign that's to the side.
Alpha.
Alpha.
Alpha, yeah. Is 0.01.
Yeah, score. So we have alpha and then we have beta. Beta would be the type 2 error. But yes, okay, alpha 0.01. Very nice. Requirement check. Notice random. Very cool. Check. We're going to check the N times P. That's greater than or equal to 5. And N times Q. Of course, that's greater than or equal to 5. So we're good on that. All right, let's go to Emma. Would you please provide to us the null hypothesis?
Null equal, or sorry, P equals 0.75.
Yes, beautiful, 0.75. I'm going to leave this up to anyone who wants to do it. What's the alternative?
P is not equal to 0.75.
Yes, I love it. What kind of a test is this?
Two-tailed.
Yes, two-tailed test. Two-tailed test. Excellent. Let's calculate the test statistic. So we have P hat 0.7813. Go through this whole process and then tell me your Z-score when you have it. And I'm just going to fill this in as you work through this in your notes as
question.
well.
When you are writing the N times P is greater than or equal to 5 up top.
Oh, yeah.
Where are you getting this 5 from?
Oh, it's just one of the requirements. So
Okay.
it's from the binomial distribution. You want to make sure that n times p is greater than that 5.
Okay.
Yeah, it's just one of, it's a set of requirements for the binomial distribution.
Yeah, but we don't have to remember them for the test.
Right,
So
right, exactly, because
it'll always be required. The
Yes.
requirements will always be, yeah.
right. Beautiful. Starring, absolutely. All right, let's, I'm still working through this. And I'm just filling in what I'm finding as I'm finding it. And just go ahead and share with the class the z-score once you figure out what it is. Rounded to 2 places after the decimal, of course.
2.07.
I guess something a little different.
1.98.
Ah, okay, yes, I got 1.98 in this case. Because it's two-tailed, we're gonna shade in 2 tails, which means we need a positive and a negative 1.98. So 1.98 is approximately here. We're gonna shade all of this stuff. And we also have negative 1.98, which is approximately here. And we'll shade all of this stuff. Good. Use your z-score table, negative 1.98.
0.02385.
Yes, 0.02385. This one's also 0.02385. We're ready for our p-value. Add them both up. And again, you don't have to write it out twice. You can say times 2, whatever your heart desires.
0.0477.
Yes. Perfect. 0.0477. We're going to write the decision about the null hypothesis, but we have to start by explaining how we arrived at it, which means we're going to compare the p-value with our alpha. Our p-value is 0.0477. Our alpha in this case is 0.01. Ooh. Notice that the p-value is greater than 0.01. What's our decision?
Reject.
Fail
Fail
to reject.
Fail to reject. We fail to reject the null if the p-value is ever greater than alpha. If the p-value is smaller than alpha, if the p is low, then null must go. But that's not what's happening because p is greater than alpha. So remember, if the p is low, then null must go. That's not what's happening. Good. We failed to reject the null hypothesis. So we're ready to write our conclusion. This time it's essentially the same, except we say there is not sufficient evidence. So there is not sufficient evidence at the 0.01 significance level to show that p is not equal to 0.75, which means the population proportion of adults who say,
We just write proportion, or do we have to write population proportion?
no, you could write just proportion.
Okay.
Of adults who say it is morally wrong to not report all income on tax returns is, and I'll change it up, I'll say is not equal to 0.75. You can write 75%. You could say is different from 75%. It all means the same thing. You probably hear my notes over here. That's because I'm turning to page 4. Discuss the type of error you could have made. I'll give you a second just to make sure that you jot this down. There is not sufficient evidence at the 0.01 significance level to show that P is not equal to 0.75, which means the population proportion of adults who say it is morally wrong to not report all income on tax returns is not equal to 0.75. Then we have to make a decision in this case in terms of what kind of error we could have made. Go back to page 4. Remember, our decision was to fail to reject, right? Fail to reject the null. I think that's going to be helpful. So because we failed to reject the null, let's go to our table. Start here. If we failed to reject the null, so we could have made the correct decision, or we could have made a type 2 error. So that means the null hypothesis. So we failed to reject the null, but the null hypothesis is actually false. Okay, so we could have made a type 2 error. So let's write that out. We could have made a type 2 error, which means the null hypothesis could have been false. Because remember, we failed to reject it, but we could have made an error. Very cool.
When we're writing out that little piece of information, do we have to include what the original question is asking?
I mean, I didn't in this case, only because we have all that information. So we're just stating what could have happened. So I feel
Okay.
like this is sufficient enough.
So like for the test, if that is a question, that's sufficient enough to say that?
Yes, absolutely.
Because I know we included the 34% or whatever. So I
Yeah.
was just wondering if we had to include that. Okay.
No, this is totally cool. This is totally cool. All right, everyone. I will be finishing these notes on my own through a video. I will put the recording on Lumen. You have lots of information from me, so expect an email with all sorts of details, okay? Enjoy the rest of your time today. Make sure that you are tackling some of the homework that you have. And like I said, I'll be extending due dates, all sorts of good stuff. So look for all of that information within the next couple days. All right, everyone.
Thank you so much.
Have a great day.
Thank you. Bye.